Mr. Minnick here, helping my students learn how to implement a class. We start with our example of a client program, which is simply a program that generally has a main method, and in this case, it just prints out hello world when it executes, and that is not very exciting. So imagine a situation where you want to develop a game. You'll need a bunch of objects, a bunch of nouns or things to operate in that world that becomes your game. Well, one obvious need will be to have a player. So a player would be something that you create as a variable, and maybe you call the first player player 1. And the player does things like it shoots or it moves. Well, to have a player, you must declare it. The question is, what data type would you use? Int, double, string, boolean? Well, none of those really match. A player is something that has characteristics. It has behavior. It can do things. So it's very complicated. In fact, you need to create a new class that will then be used as the model, or as the model for these player variables that you'll create. So you always name a class with a capital first letter. Generally it has a noun. You would not name a class shoot. That's a verb. That doesn't make sense. And that allows you then to create a variable with an object variable with any name that you want, and to give it the data type player, because this exists. And you can declare it, tap on the semicolon there, this compiles and this does execute. We're still only printing hello world, that we're not doing anything interesting, but at least we have declared an object variable that can be used in this game. But what is a player? Somebody who's designed this game must tell us what the player's state is and what the player's behavior is. Now, state is commonly thought of as instance variables. And we must declare those instance variables. And the behavior of the player would be its actions, the things that it does, the verbs. Well, we usually call those methods in Java. They're just known as methods. So there are two parts to a class: state and behavior, also known as instance variables, and then methods. And this would just be the method definitions. Okay, so what is a player? Well, I hereby declare that a player has 3 important attributes, 3 important properties. Another name for instance variables is often called properties, and there are some other synonyms. Let's say that a player has a health, it has an X location and a Y location. Well, it's good style, especially in this class that I teach, that early in the school year, we always name instance variables with the prefix my, and we capitalize that next letter for good style. So let's tack on the prefix my. And we have to decide carefully what data type each of these instance variables are. Well, our choices are either int, double, or string, and I'm just going to choose int for all 3 of these so that whole numbers could be stored. So really we have a variable that consists of variables. This is an object variable up here in the client program. Player 1 is an object variable. These 3 properties are better referred to as instance variables. Make sure you know the difference between object variable and instance variable. Anyway, we need semicolons here. Do not set these equal to 0. That would be considered bad style on the AP exam. And you should always make instance variables private. So let's do that. We'll learn later in our school year why they should be private. it would make no sense, and you should not type the word private up in public static void main string args. Never up here in the client program do you use the modifier word private. Okay, so far so good. This still compiles. It still runs, but nothing meaningful happens other than our good old hello world. Okay, what's next? The next thing you would need to do anything interesting would be then to maybe display what the health is. Well, what is the health? I think by default, 0 is stored in integer instance variables, but let's just be sure. So for that, we need what's called a constructor. So there are two types of constructors. There's a default constructor that you should place in every class for good style, and then there are just plain constructors, which I call other constructors. So there are two kinds of constructors, and we're going to create a default constructor first. The job of the default constructor is to initialize all of the instance variables. So I need to set my health equal to some initial number, and let's say that the health starts at 100, just to be interesting, whereas the position of my x starts at 0 and my y starts at 0. And we should document this and explain that this is a number between 0 and 100, where 100 is perfect health, and perhaps 0 would be dead. The x is where on the grid between, say, negative 200 and positive 200 on the x-axis, and maybe we have a square game board where y also ranges from negative 200 to positive 200. So please always add comments to your instance variable declaration statements so that other developers know what you're doing. And we have this default constructor. But it needs a method header. All methods need a header. And the header for a constructor is simply public and then the name of the class with a set of curly braces. And for good style, we indent this code. Now we're talking. This is a default constructor for the class player where all of its instance variables are being initialized to some number. Do not put the 100, the 0, and the 0 up here in these declaration statements, but rather use assignment statements to do that here. Do not put the word int here. You've already declared my health. Don't redeclare it. That would actually be counterproductive and cause problems. Okay, so now let's bring player 1 to life. Player 1 equals new player. The keyword new, the operator new has to be used here to invoke and call this. So by having equals new player, the computer executes these 3 lines of code because the player empty parentheses matches up with the player empty parentheses. And this line of code is technically an example of instantiating an object or constructing it because you're calling the constructor. And normally we don't go around breaking these 2 lines of code up, these 2 actions up into 2 lines of code. Normally we do all of this together, the declaring part and the instantiating part. So let's do that. Let's tie it together here. And now I guess you could properly say that you're declaring and instantiating an object. And the name of the object variable is player 1. And let's compile and run this. And we see that we are not getting any errors, and it is executing, even though right now it only prints hello world. So let's verify that the 100 actually was stored in my health. Well, we could throw in a system out print that tries to verify that. But let's first just system out print player 1. Let's just see what happens if we system out print player 1. It compiles fine, and it runs, but look at this. It prints this nonsense. It prints a hash code value with a hexadecimal number, something to do with where in the memory of the computer player 1 is stored, something like that. You don't need to really know what this is. This is a logic mistake. So did you expect 100 to print out, or 0, or this 0, or did you just expect all three of those to print out? Well, sorry, it doesn't work that easily, so we need to type system.out.print player1.myHealth. Now we will print the 100 with this line of code, because, just to space this out a little bit, we are accessing the myHealth instance variable of the object variable player1. Let's go for it. Let's compile it. Oh, but we have an error message because myHealth is private. Because it's proper style to make all instance variables private, up here on this side of this, this division, up in this class, you cannot access anything that's private down here. And that's for a good reason. I'll explain later in the course. So right now, let's just realize that that was a mistake, and you should not do that. Now, note that if this were public, if myHealth were public, then this will compile, and furthermore, it will run and print out the 100. See that 100? That 100 is this 100 that when we constructed player, the 100 was stored in myHealth, and we are legally system out printing it because it's public. But that's bad style, and you would lose points on the AP exam, so don't do that. Okay, so to print out health, when this is private, we need an accessor method. So your accessor methods should go in their own like little area of your class. Each instance variable should have its own accessor method. Accessor methods should always be public, and they should always be named with the prefix get for good style. And do not name it get my health. Just trade off the prefix my for the prefix get, capitalize the H, and realize that because it's a method, it needs parentheses here, and of course it needs curly braces for its body. Now the purpose of get health is to take this 100 and send it up here so it prints. So we are going to be returning an integer, and we have to put that return type here. And because we're returning something, we have to type the keyword return and what it is that we want to return. So trust me that the 100 is properly stored in myHealth, and by typing return myHealth, it will return that 100. Do not just type return 100, because eventually it could be other numbers other than 100. Now you ask, but isn't myHealth private? Why is that not causing an error? Well, because yes, myHealth is private, but we are currently in this set of curly braces here in the player class, so we can make use of myHealth. And now up here in the client program, by changing this reference here to get health, you need empty parentheses though, because you're calling a method that has empty parentheses and no parameters. You do need those parentheses there. And now we will see 100 print out, and this is a better style because myHealth is now private, but yet we can still access it with its accessor method. See, the 100 prints out. So I'll leave it as for you to do as an exercise, but my X and my Y should also have their own accessor methods. So put that on your to-do list. Implement the get X and get Y accessor methods here. And I will finish this video out by providing a other constructor. One other constructor would be, let's say that we wanted to create another player in our game, perhaps called player 2, but we don't want it to be have a perfect health. Let's say we want it to be like half healthy. So we can pass the number 50 down to a other constructor. And while we're at it, we want its position to be 0, 0. No, that doesn't make sense, because then the player 2 would be on top of player 1, which is starting its life at x0. So let's just start it at the x position 20 and the y position, say 30, and now let's make this interesting. Okay, so 50, 20, 30, three actual parameters are being passed down to this spot right here. All methods should be public. The name of a constructor is always the same as the name of the class, capital P. But in this case, instead of empty parentheses, we need three things. We need a formal parameter for health, a formal parameter for x, and a formal parameter for y. You would not use the prefixes my here. And in this case, we should use a whole word in case other people don't pick up on the fact that health is H is health. We do need data types here that match the data types of the actual instance variables. And in the body of this other constructor, you would simply transfer whatever is being passed to health, whatever number is here in that first position, 50 in this case, plugs into health, and therefore we should take that number and that 50 that's plugged in there, and we should assign it into the instance variable myHealth. Assignment statements with an equals symbol always work from right to left. So the 50 comes here, it plugs in here, and then it plugs in from right to left and plugs into myHealth. And we should do the same with x and y, plugging them into myx and myy. And there you have it. That's a typical other constructor that would allow this line of code to execute. Let's test it. Let's system out print player 2's health to make sure it's 50 and not 100. So player 2 is the name of the object variable. Get health is the accessor method that we're making use of. And here goes, compile and run, and we should see the output down here shortly. 150. The 100 refers to player 1, and the 50 is player 2. Okay, there you have it. I'll add one more other constructor just to show you that you can have multiple other constructors. You only ever have one default constructor with empty parentheses, but you can have different combinations. So let's say that you want to allow the person to create a third player in this fictitious game. And in this case, they can start with a health of, say, 100, but at a random position so they're not over top of player 1. So by having just one parameter there, I can create a third constructor down here, a second other constructor that takes just one parameter. And you can reuse the name health as the formal parameter. This health only has scope within this set of curly braces, so it will not interfere with the health that's named here. Okay, so my health equals health. In this case, the number that I plug in here, 100, does plug in for health. Oh, you ask, how does the computer know where to send this 100? Well, because here, this constructor call statement only has one integer parameter. This has 3 integer parameters, and Java is just smart enough to know when to use this other constructor with 3 parameters, and this other constructor that has just 1 parameter. Okay, but let's generate a random number for x and y, for my x. So my x is equal to math.random, let's say number between 0 and 100, and my y is equal to a random number. And if you haven't studied random numbers yet, you can study those on your own. This is a decimal number between 0 and 1, 0 inclusive and 1 exclusive. We have to turn this into an int with typecasting. So let's do a little typecasting there, or we could use probably math.floor or some variation of that. But this will work. So whatever this random number is, decimal number between 0 and 100, we're chopping off the decimal places. And let's now print out the health of player 3. But more interestingly, let's concatenate to that, and also print out the after space, let's do player 3 dot get x. To have get x be a legal method, I must implement it, and that was on my to-do list, so I'm quickly going to copy and paste this and give you a freebie here, and change this getter to get x, return my x, and now it's only on your to-do list to implement the get y accessor method, and you should put the y below the x. That would make sense to put it down here in this spot. Okay, let's run the program and see what random number we end up getting for the x, and also ensure that player 3 has a health of 100, whereas player 2 has a health of 50. Compile. Oh, I have an error. I missed a semicolon somewhere. Sorry about that. Right here. Even teachers make mistakes. Okay, compile and run. Here goes. Okay. 0 was the random number. Oh, that was weird. Oh, we have to put an extra set of parentheses in here. Another logic mistake by this teacher. Because of the order of operations, the typecasting typecasted this random number between 0 and 1 and turned it into 0 before it even multiplied with the 100. So here goes. Okay, that was a random exposition of 87 for player 3. Let's run the program again. And this time it was 21, and I could keep running the program and see that this player will have different x's, and of course there's a different y. Okay, there you have it. You can scroll through this video to make sure that you understand how this client program makes use of this rudimentary but worthwhile player class, and we have a lot more to learn after this.